And we're live. And my thing has you centered, whatever. It's fine. It's fine. Well, here, we can go over here. Welcome back to PinForge. Hope everyone's doing well. Hope we look and sound okay. If not, let us know in chat. Kind of running with a skeleton crew right now. A few can't join tonight, and the others are yet to join. So, still might be a few late additions. But you got me and Jeff. So, what could be better? It's quiet, you know. We don't have to listen to nonsense from Mr. Trophies. Jimbo Gunn sounds good. Dan sounds good. Appreciate the feedback very much. Thanks, gentlemen. Yeah. So, kind of what the purpose of the stream today was going to be was to review the updated CAD with all of the changes that we tested. So we did some 3D prints on the last stream and had those mounted to the playfield, and we did some flipping out in the garage to get a feel for the ramps to see if the flow was good and if the decisions we made were correct. I think personally, after flipping it, and I think from the team watching me flip it, I think we're on the right track. I think, in my opinion, that they're good changes. But I don't know, Jeff, did you get a chance to watch or you were on it last stream? Sweet. Kyle's trying to log into Teams still and failing. He's tapping out. Mr. Awards has had too many trophies. He's calling it quits on this one. But you got me and Jeff, and I know Aaron will probably join in a little bit. Bosch is usually a little bit late because of the time zone he's in and his work and when he gets out of work. I know Ernie's traveling, and haven't heard from Moogly Moog in a minute, but I anticipate he will join. So, those changes. Let me bring up the Fusion file, and you should be able to see that. And let me know if you can't. But so this is the updated Fusion file. First thing I'm going to do, I'm just going to hide this left ramp right now, just so we can kind of see an overview of the playfield. And it probably helps if I change this camera to perspective, just so it's a little bit easier to visualize. So the changes that we made were some minor, some major, and I think we kind of talked about them the last live stream. A lot of lat rail redesign in this version. Some movement of mechs, so like the drop targets moved around a little bit, so things meshed a little bit nicer underneath the playfield. Jim is asking if Jeff said something. Hold on. Say something, Jeff. Okay, no, I need to set the audio output there. Give me 1 second. Output. Say something, Jeff. Output. Headset. Realtek Digital. Hey, streaming's easy. Have that set there. Have that set there. Set it up here.
Let's turn on some lights.
Now we should hear you. Cool. My bad. Thanks, Jeff. Thanks, Jim. Appreciate it. Okay. So, to recap what Jeff said, he said he liked the changes, and I am amazing at everything I do.
That's a stretch. The changes looked good.
Darn it. Okay. So, anywho, what I was saying. So we made quite a few different changes based on feedback from TPF and what we saw as people were playing. It's kind of hard. I guess I can maybe turn on some of the old stuff. So let me turn on the old right ramp so we can see what that looked like. So at TPF, people saw this right ramp here, which is kind of a bit ugly, kind of visually intrusive in the playfield. Hide the vacuum form. And it was kind of a pain to see underneath. And the new design over here, this right ramp, is designed of metal. And so this was a pretty involved process to design this from metal. It took me approximately 12 hours, 14 hours, roughly, right? Alex, how's it going? Welcome.
How's it going? What took you 12 hours?
The right ramp design on Sunday.
God damn.
Well, it was a combination of the right ramp and the drop ramp and verifying all the post placement and which posts we wanted to use. The ramp itself wasn't 12 hours, but...
Is there any physical iteration in that, or is that just purely on the computer?
So this was, if you remember the last stream, we had the 3D printed one. So this is the same geometry, just modeled as sheet metal.
No, I'm asking about the work hours. Like, is some of that doing physical stuff, or is that all computer?
It was all computer.
Gotcha. Cool.
So the CAD slows down quite a bit when you get a big assembly file. Part of that's on me for, in Fusion, they want you to create components as their own files, bring them together as an assembly. I find that when designing a pinball machine, it's easier for me to do it all together so that things kind of fit together nicely. You're not trying to bring in a component and orient it and get it in place. You can design it all off of a single sketch within Fusion and then extrude your walls to get everything where you need it. And they made some changes in this version of Fusion where when you create a new component, you can optionally create it as a linked component, so it'll automatically create a new file outside of the assembly file. I didn't leverage that for this just because we were halfway through design of this when that update pushed, and I didn't want to change what I was doing. But I can go back through and clean up this file and remove some of the all the other posts and stuff that we didn't end up using.
Gotcha. So there is leftover component stuff in there.
Yep.
Is there a BOM export?
Yep, so there will be a BOM export, which is why I'm going through the trouble of bringing in every standoff, every post.
Right.
Just so we have that captured. I haven't brought in any screws yet, just because threads tend to really slow down Fusion. So I may bring them in later, but these posts, the models that I have here are models that I created, and there's an option when you're doing threading to not model the thread, but just it paints on this visual appearance of it, and that's
right.
a lot less taxing.
We don't even need the visual appearance. It could just be fully off.
Yep.
Yeah.
Yep.
Yeah. If you can generate a BOM, my company is procurement software, and we do importing bombs and AI ingestion and stuff, so it'd be fun to play with.
Oh, cool. Yeah, there's an add-on that I have in here right now called Open Bomb that
see.
will generate a bomb, and I think there's some built-in bomb functionality in Fusion as well.
Gotcha.
Before I do that, though, for this, and this is something I'll work on over the next couple months, is every single component in here, I would like to add more properties to those components to define like the cost and like possible sourcing options. I think that's things that I can put in detail for properties, and then when it pulls that bomb over, it'll pull over like, here's the price, here's some resources to go buy, that kind of thing. That's gonna take time though.
That sounds like my job. It's all very familiar.
Yep.
Yeah. I learned what should cost means. Do you know what should cost means?
Is that based on current market rates for material and
Labor
estimated labor
and stuff? Yeah.
Yeah. So like what it should cost versus what you go out there and find.
Right. Not a target cost, not an actual cost, not a quote, not an estimation of like the future price of something, but what it would cost you. It's what an industry. Anyway, I'm excited. So what's the topic for today?
So today was going to be reviewing the updated CAD changes, mostly going over the right ramp and center ramp designs, maybe in a little bit of detail to show like what the flat patterns look like for the files, and possibly stepping through what designing one of these ramps looks like, because I have the timeline feature. I can go one step at a time and show
Cool. Does that work once you've left the program? Like, is that something you can do after having saved and quit and rebooted and everything, or is that only because you've been editing?
Yep, so Fusion 360 is, I think it's called parametric modeling, if I'm not mistaken, and it has timeline features, so everything like references previous sketches, geometry, and so on and so forth.
Gotcha.
So
Okay,
that you can go back and edit something, and then it'll affect everything downstream, right?
Gotcha. Yeah, I just go into the sketches and change something about them, and usually it comes up with like all the moves afterwards apply properly. But
Yep.
I'm a noob with this stuff.
That's fair. No problem. Everyone starts somewhere with CAD, and not everyone's comfortable with CAD either, so kudos to you stepping into it.
So something I've been working on was the Bash toy, but not the art or the sculpt or anything that's impressive about it. Now that I've seen some teasers, but instead the sensors. So we have this little, where's the camera? These little vibration sensors, and there's 3 different sensitivities.
Full screen.
Oh, am I not on? Yeah, there we go.
Yeah.
So we have this vibration sensor from Adafruit, and there's 3 sensitivities of it. It's an interesting one because it's not going to focus, but there's like the thick leg, and then like a really like easy to bend small wire, and they even get to like touch or whatever if you're not careful. So I modeled a little housing that we can, I'm not good at putting it on camera, there we go, that we can mount it into and screw it into the back, like interchangeably. So
special order this, but this is a true.
Nice.
What am I hearing? Special order something?
I think that was Jeff.
All good.
Ernie, welcome.
But yeah,
I'm not sure what that was.
yeah, did somebody just join? Ernie, what's it going? How's it going?
Hey, can you guys hear me?
Yeah.
Just jumping on for a minute. I'm in the car, but I figured I'd jump on and see how things were going. Is that the
Sweet.
little sensor for the Bash toy?
Yeah, so I modeled like a container for it so that that holds it down in a certain direction so we can just screw it in to the back of the toy.
Okay.
So it'd be a nice, like, interchangeable, testable thing because I need to see the different performance of the different units.
Gotcha. And I think you and Moog and Eric are working together on the design of kind of said mech?
Yeah. Right now, I'm just trying to make the sensor work. I haven't actually tried to plug it in, but neither of the leads are long enough for a Wago, so it's like, oh, I have to go solder this. Okay.
Brush off those soldering skills.
It's homebrew. It's fine. It's just a Wago is easier.
Yeah, and that could be something. So does that sensor have to be facing like straight down?
I have no idea.
Okay.
So tonight, tomorrow, sometime, I will have more info.
I'm wondering if it's something where it has like 3 different diameter or gauge springs inside of it, and that's what it uses.
Springs inside, yeah.
Very interesting. So we'll use that for potentially 3 different levels of hits.
Yeah, that would be the dream. Like, I have Iron Maiden downstairs, and it sort of has that jump ramp with the 3 levels of target, and it's, I think, just 3 different switches, and, you know, you'll bash. If you hit it right dead center, you do poke that middle one, and then get, like, higher score.
Gotcha. Yeah, that'll be cool.
Shot quality is a cool thing to measure in a jump.
Yeah, and you could... So I'm wondering, that's not like a 3-axis sensor, right? It's just like 3 different levels of vibration or whatever?
Yeah. Ultimately, it's just a switch that closes, like from MP's perspective. There's no quality, there's no, like, levels to it. It's just open or closed.
Oh, okay. Gotcha. Well, cool. That's fun.
Yeah, so, you know, lots of different aspects of the project moving forward. Code's going. You know.
Yeah, I'm debating if we want to, like, show what the sculpt looks like, or save that for when it's ready.
Do it.
I don't know. I can't see anybody else's.
Go hard
on here.
Let me figure out how to pull up some pictures here. Is there an option to download all? Of course there is. Alright, let me save the images out here. Renderings.
And I think, you know, nothing's final, not really even close to final, right? We need to figure out how these sensors work, how we're going to mount them, connect everything. Is this going to be on a spring? But, you know, we do know that it's going to be over in that left area behind the VUC with that back entrance. So where that left ramp cutout shoots to.
Yeah, and kind of where my head was going with that, and I kind of mentioned this in the Discord the other day, is having a place for the ball to drop after you hit it. So that's kind of why I was thinking you mount it back behind the VUC, and why we have that subway entrance there in the first place.
Yeah. Yeah, exactly.
Okay.
But I think, you know, one of the big questions is going to be the size. Like, how much headroom do we have right there, and how much space do we have to use mounting it, for instance, and putting redirection plastics so that things do fall into place instead of getting stuck.
Agreed. Okay. I have the photos. Let me File Explorer and then share my screen. Appreciate everybody's patience. And it went there. Perfect. Alright, switching over. Here we go.
Hell yeah.
Check that out. That is Cooter McGee.
It's a render though, right? Like,
I'm pretty sure it's a render. Yeah, I was like debating, asking last night, Eric, if you had 3D printed it in resin because it kind of looks like a resin print.
It does. It looks convincing. Maybe there's too much AI out there now. It's too easy to be fooled.
Right.
But no, this is incredible. And like, yeah, I'm glad I got to show my dinky little part of this first, because this is so much more impressive.
Yeah. I mean, Eric just does incredible work. Love everything he's brought forward so far. Really happy that we brought him on.
Yeah.
So this is going to be a bash toy on the play field. Above the, like, mounted above the upper left flipper, and slightly behind the VUC that's right there. So that way, as you hit them, the balls can kind of drop into the VUC, but, you know, we expect there'll be deflections and everything too.
Yeah.
But giving some sort of an intentional collection point, I think, is going to be important.
Yeah, because I think there's the you hit and you drop in, and then there's the you hit and it just kind of deflects and keeps going elsewhere. You know, you might want to have that behave differently. But yeah, what I'm thinking of is, like, with this model, like the sensors can mount in the barrel probably from behind, or maybe just in his back, in his lower back. You know, we'll see.
Yeah, and this might end up being something where, like, the flat of his back is where we're anchoring some sort of a stainless steel tongue or flange that's maybe on a spring or something, I don't know, but
yeah.
Mounting him is going to be half the battle here.
Yeah.
But yeah, I mean, just incredible detailed work from Eric and his imagination of bringing these, bringing these characters to life.
Yeah.
Really cool.
I'm just glad I have a multicolor printer, so I don't have to paint it. I can just print it in multicolors.
Right. Now, the day that they have, like, the multicolor resin, that will be... I'm sure there's probably something out there, but I'm not dropping 50 grand on a printer.
Aaron.
We got user 443. Been watching some of y'all's streams. Interesting stuff. Appreciate it. Eric. Dooley Dolly. Let's see that sculpt. I can't wait.
Yeah.
I think Ernie's already printed one.
Yeah,
Alejandro?
I've got a multicolor printing now.
Cool.
Yeah, I
Printing
did
gel?
print it, but it was just a single color print, just to see what it looked like, and it looks awesome.
And Jeff, what did you say?
I'm printing in multicolor now.
Hell yeah.
Yeah.
Now we need him with. Now we need, like, a version with the arms down, and he's at a pinball machine.
Yeah, make a rigged character, please, Eric.
just two positions. But
Yeah,
yeah, so yeah, you're looking right where you're showing off where it'll go.
Could probably
I think,
import it.
The
really
biggest difficulty is going to be stuck balls sort of on the left corner behind it. So, always a concern.
Right. Yeah, and that's something where we might need to do some strategic plastic placement.
Yeah.
Actually, I'm gonna create a new design and import them both there.
Are you just going to import it right now?
Yeah, I'll just import it right now. Why not? We can play with it a little bit.
No big deal. Now that everyone's seen it, I mean, just put it right in there. But yeah, so also, because we don't know the headroom, I guess we can choose the scale, and that actually is what. Do you have a glass layer where you can tell where the headroom ends?
I do not. That is something that so what I would like to do, and I can do this with some of my files that I have, is kind of estimate where the glass is, but
Yeah.
I would like to just drop this in to a cabinet and then measure the height right over that area, rather than kind of guesstimate a drawing of a cabinet design.
And I think we have to be a little conservative also, just because other people will be making this and may have subtle variation in parts and everything. Everything should be consistent, but an extra half-inch of space is maybe reasonable.
Yeah, I think we want to probably plan for half-inch, and we should also think through the different cabinet types people can use.
Yeah.
So, what's the height to glass in a Stern style cabinet versus a Williams versus a Barrels of Fun, and like the type of hangers that are used for each of those, and angle the playfield, that all plays a factor into the space in that area.
Never mind. We're just gonna go with whatever I have in my garage
Well,
and not deal with all the complexity.
part of the design that we're trying to do with this too is make it universal for whatever type of hardware people end up using. So if we look at this playfield, for instance, I have hanger holes for both Stern and Williams mounting locations.
Right.
So if you're using a Stern lockdown bar versus WPC, we kind of accommodate both of those.
Hell yeah.
Something that I think is different from, and I haven't 100% verified this yet, but the pivot placement also varies from manufacturer to manufacturer. And I think it's relative to the back, because I'm pretty sure for Williams there's like an extra inch of length.
Gotcha.
But I think relative to front, that's largely unchanged. But I need to verify that. Okay, let's try to import this maybe.
Yeah.
Can I import it from Bootleggers? Like, it doesn't want to let me right click and insert it. You know what? I'll just insert it into this file and scale it. Watch, it's like massive. Or tiny.
Oh.
Oh, it's a little cooler, Biggie. He's just a cute little guy.
Destroy him.
Oh, jeez. Roughly that direction there.
Scale it up.
Then
It's...
let me turn off perspective. Then how can I love it doesn't give me an option to scale it right now, which is I don't do a whole lot of messing with mesh bodies in here. Modify. No, I'll do both.
Right, they should be the right size. Nice.
Roughly there. Maybe a little bit bigger.
Oh yeah.
I think we said we have, what, 4 inches, we think, to play with there?
I don't know.
Kind of right about there. Honestly, that's not a bad scale right there.
Yeah. And then sort of, I was imagining that it would be much more left oriented and blocking, but this way it kind of gives you a nice
Yeah, it
like
kind of corrals.
legs, or
Yeah, because like
and then you
it
can
should
still
kind of
deflect it,
direct
but-
balls to the left if you hit him like left of his left leg.
Yeah, but then that can just be a bowl in there.
Yep.
Yeah. Okay. Nice.
And then if we design the plastics correctly, it should be able to roll off behind him. This orientation is actually really nice. It kind of works really well for the space.
Yeah, I think the alternative was cutting, somewhere at the waist and doing a bigger bust, so you can get a little bit more like character detail. And then the barrel is bigger, but I like this as well.
Yeah, I mean, we can do either or. I do like having his full body there because it gives him more kind of like animation in pose.
Yeah.
Shows
But
a little
then-
bit more aggression with how he's like leaning forward and kind of stepping towards you.
Yeah, I think it's a trade-off with that, and then like the physical aspects of actually doing the mounting and sensor and wiring and fragility. So
Yep.
I think we got to figure out a way to mount some, print it up, and then have you bash it a bunch.
Yeah, bash it 100 times plus and see how it holds up. So you can see in that area I have 3 posts available for us to use for mounting, and then pretty much everything in behind here we can relocate posts and do what we need to with brackets.
Yeah, I guess I imagined that it would be on some sort of really strong spring, but still have some ability to take the impact and
Agreed.
distribute away.
Yeah, we need a spring that is strong enough but not too strong, because you don't want it to be like thrown back at you. It needs to absorb the shot enough to let it drop.
Okay. A lot of fun materials questions.
Yep.
Different kind of engineering that I've done before. So yeah, this is fun.
Yeah, we'll just place them right there for now. That's gonna really... Fusion's gonna love having meshes in here now. Cool.
Now let's just let them hang there, hover a little bit. So you were going to talk about ramps and design and other stuff you wanted to go over?
Yeah, so mostly I just kind of wanted to review the 2 ramps that I designed out of metal, and potentially step through what the design of one of those ramps looks like from a Fusion perspective. And that's where we can leverage this timeline that's in here. But before I got into doing that on one of the ramps, I just kind of wanted to showcase, so for the left ramp, left center. We'll call it center ramp. For the center ramp that you saw on the last live stream, we were testing the 3D print of this ramp to make sure that the geometry of it worked and it flowed really nice, which it did. And then I took that same geometry from the same sketch and I created a metal version. And the metal version's nice because all of these components you can order through Send Cut Send, laser cut with hardware inserted and everything, and then all you have to do is assemble it. We still intend to do some vacuum formed ramps in here as well to kind of showcase both options. But I think as far as these 2 ramps are concerned, metal will be sufficient. Question in chat from Alejandro. This is a kit you plan to sell for people to assemble on their own. When this kit becomes available, does it come with a cabinet or wood to assemble into a cabinet, or do we find one on our own? So that's an excellent question. What we plan to do, so this is completely open source. Everyone on this team is volunteer. And we are going through the process of designing a game from start to finish, and then we're going to be publishing all of the files for it, including reference bill of materials with links to where you can go buy some of these parts. So like through Marco or through Fast or through a cabinet supplier, we'll give some pointers on where you can get some things. We'll always have Discord to help with questions on sourcing as well, but we're trying to make the instructions as clear as possible. And we're also trying to offer different options of complexity for people as well. So, Marco may have a kit that includes everything you need to build this game. So you can just one-click buy and done. Or if you reference the bill of materials, you can just buy one component at a time as your budget allows. So want to leave that option out there for people. But we're not directly selling a kit. We're just going to work with different companies out there in the industry to be able to make it easy for you to buy the stuff to build this. And then once we have all the files for this available, we're going to film a follow-along DIY video series so that you can build your own copy side by side right there with us. Eric, is there a specific open source license you intend to release it under?
Hold on really quick, just back to the previous. He also asked a lot about cabinet in particular, and like ideally it'll match, or we'll have different plans, like different guidelines for different cabinets, because they do have slightly different, positionings of, the rails and lockdown bar, etc. But from experience, the cabinet is the hardest part to source. Unless you want to make it yourself, getting a nice, clean cabinet that's ready for pinball takes a long time. There's flat pack options; they take a long time. So I don't know. Just a realistic take here is just like if you want to make your own homebrew or bootleggers. Or restore a play field that you got for some other game, right? Like, get on the cabinet as soon as you want to commit to that project.
Agreed. Yeah. I mean, there's a lot of variance between manufacturers, and sourcing them is going to be a little bit of a challenge. The best we can do is provide guidance on where you can go for different options, and then try to make this as universal fit play field as possible.
And I am working through some options through Marco. Nothing concrete yet, but working on a couple options that might be able to be used. But it's all, it's none of it's confirmed or for sure. Yeah, but I'm working on some different routes that we can do.
But upside is also we want to choose components and pieces and even the send cut send metal, like make everything that we're choosing available enough that you can get it. Like, the point is that people can make this game, so we want to make sure that everything is obtainable.
Yep. And then if there's any like custom mech creation or anything of that nature, everything is published and designed in a way where you can go buy the brackets through send cut send or however you want to do it. So there will be a few custom mechs, but we'll make it easy to source those. Like Alex said, the hard part is the cabinet, and that's something we still have yet to figure out.
And the number one hard part is the money anyway, but we could talk about pinball being expensive forever. So there was a question about open source and licenses.
Yeah, I'm not prepared to answer that. I don't know if you guys know more about the licensing for open source than I do, but
it's different for different kinds of media. So the license for the code will be different than the license that you would use for art, which would be different than a license for other aspects of this. So getting that exactly right is tough. It's going to take a little time. I do open source coding. I like the MIT license. I would think that we would lean towards that more than, say, GPL. But
agreed.
Our team needs to discuss before we commit to it.
I think, loosely said, the spirit is open source with the intention that you aren't going to grab this and go make a bunch of money off it, selling it as your own.
When I know...
To Alex's point, that'll be tightened up and we'll determine what the licenses actually are. But the intent is something that people can use to build a pinball machine and really learn, but not go out and make a commercial endeavor for themselves.
Correct. But we also want to leave the license open to a point where you can build this game, put it on location, and still earn from it. You just can't commercially produce this game.
Well, I think this is all, we still need to figure everything out. I think
Right.
as a team, what makes the most sense. But I know we did discuss the potential of, like, if a commercial place was going to route it or have it on route, that we would have a license for that. But I don't know. Oh, there's a lot of discussion that needs to happen behind the scenes before we concrete have any kind of answer.
I mean the less that we get financially involved with stuff, the less support we give, like, is sort of that. There's like a correlation between that. Like, we're not the same as Stern, and problems you have getting support from Stern or your distributor or whatever, right? So yeah, it'll be an interesting thing to figure out. But this is part of why, like, the code and the assets aren't available yet, is because it doesn't make sense to put some of this stuff out there before you have the stuff in order, licenses.
Agreed. Okay, so we've got roughly 15 minutes left here. I kind of wanted to just focus on the design of this right ramp just for demonstration and show how I designed it and how we intend to mount it. So you can kind of see here the complete assembly. There's a few different mounting points. You have 2 press fit studs in the metal flange here at the bottom. We have 1 standoff in the back that will screw down into a T-nut in the playfield. And then optional, depending on like the stability of this thing, there's a spot here where you can put a metal spacer with a wood screw down into the wood rail. So if it comes down to it, we can use all 3. I don't know if we'll need to be honest. I think the studs and the hex standoff will probably be sufficient. So yeah, what does the design look like for this ramp? And that starts off with sketches. And let me make sure I have all of them. I think if I step through this, it'll actually show the sketches as it does it. But I need to find the other right ramp ones I used. Be under here. Yeah, there we go. Nope, there we don't. Not the one. Apologies.
Come on.
It's okay. At the same time, I'm trying to figure out how to full screen your screen, and I just, after months of this, I still have no idea.
I think if you right-click my screen and
I'm on an iPad.
Spotlight. If I spotlight for everyone.
Oh, actually, that's good. Yeah, I don't have any options for that through the iPad interface.
Okay, I got you.
Cool. This is great.
That's the one I'm looking for, right? Ramp V2. And then I need the side profile of it, which I believe.
So these are 2-dimensional sketches to start?
Yep.
I guess they have to be. Everything's 2-dimensional to start. Okay.
Okay. So this is kind of a bit of a visual mess here, but ultimately this starts with two sketches. So you can kind of see here how I have it sketched out. I start with a top profile, and I use some construction lines so you can kind of see here and here me testing the angle of the ball coming into the ramp off of the flipper and understanding what that collision point looks like on a wall placement. So in this case, I decided to bring this wall in a little bit, which you can kind of see there. I decided to bring that wall in because I wanted this ball to be forced over into the outside curve, so that when you shoot this right side here from the lower flipper, it'll still deflect over into this curve and ride it nicely. Additionally, if you shoot this curve of the wall here from the upper flipper, I wanted it to ride that wall up and again force it over into the outside curve of the wall. So versus if I had this wall going straight up the center here, that ball could potentially hit and like rattle back into the point and then fall back down the ramp. So the intention with walls is to force the ball where you want it so that it follows the curvature how you want it. So I start out with a sketch drawing the profile of the ramp. So I have the walls, I have these little holes for the tabs to poke through, all sketched in here. And when you're sketching these out, it has to like match the curvature, it has to match, the sides of it have to match the, what's the center point to outside a circle line, whatever. There's names for that I am not a geometry expert. But anyways, sketch the whole profile, including the bottom and the walls. And then I come over and you see I have a side profile. So the side profile I use to see the curvature of the ball coming in off of the play field and just make smooth transitions in that ramp. And then I offset the sketch up for the total height of the ramp. And that's
Good.
essentially it.
No, I do not.
Ernie, you're off mute.
Back to me real quick, Arthur.
Ernie's gone.
Ernie's gone. I heard Marco or Emoto for a second there. I swear. Okay, so that's how it starts. It starts with those sketches there and there. So if I back this timeline up, and right now I have this right ramp selected, if I back this timeline up to the beginning of the right ramp creation, we can step through one by one. And you'll see what this is doing. And it's probably going to be a pain in the butt. We zoom fit, maybe? Oh. What if I just hit play? Can we see everything? Yeah. So you can see me sketching the 3D ramp. So this is what we test printed. And now I'm sketching the bottom of the metal, doing different extrusions on the walls, using those sketches I created. You see I've had from time to time, let me stop this. From time to time I have to well, that's why, because I don't have the bodies showing. Hold please. That's right, ramp V1. 2. There we go. Okay. So now we can, in theory, step through these. So this is me doing a 3D printed ramp using that same sketch. Step through one at a time. Add some standoff so I can mount it to the rail and secure it in place. And a few other mounting holes so I can screw it to the play field. And then I created a sketch. And let me hide that thing there. So there's the bottom of the ramp. So I start out doing a full extrusion of the profile. And that includes like the curvature. So I do the side profile, extrude that a length at which it exceeds the bounds of the ramp. I then use that sketch that I drew as the bottom profile to extrude and cut away the edges. So I have kind of a shape from top down that matches the sketch I made. And then I do some extrusions at the bottom there for that flange to clean that up. I add the top portion, which is the easy part. That's just the flat part without the bends. And I don't know what I did there. Oh, I extruded some more of the holes for the tabs. Then I convert it to a sheet metal body. Right there. And then now I start the walls. So I extrude the wall profile again from the surface all the way up to the full extent of what'll be at the top. And then I trim it using that same side profile sketch I did. So let me bring that sketch up again.
So does Send Cut Send do the slight bends and curves?
No. So Send Cut Send does precision bends. They have a set radius with their die. So it's always essentially the thickness of the metal is your interior radius of a bend. So in this case, this is 1.52 millimeter stainless. So the inside radius is 1.52 millimeters. Now, it's not like precise when you upload a file where if you have a super wide radius bend, it won't say we can't do this. It'll just detect the center bend line and it'll try to fold it at their set die radius. You can't do large sweeping curves. So you have to model them. I'll have them bend like flanges and things, but I hand bend everything else.
So then that's just part of the guides and to
Yep.
do stuff for people is like, okay, you've got these flat pieces and you have to bend it.
Yep. So
Yes.
Send Cut Send, and I still have to investigate this. You can partner with Send Cut Send to create a shop on there. So they'll have a catalog of all the files you need for this game that you can go, and they're already configured on their website with the bends and the hardware and everything. So you can just add to cart and order.
Right.
Then when you get it, you'll do like the sweeping bends by hand and feel that out. So the reason why on the side profile I have this giant bounding box is that so when I come back through, and let me look at this sketch. Oh, deselect. Look at. So there's the view from that sketch. So when I was doing that wall, I have this whole perimeter around the outside of it so that I can select each of these profiles and then extrude to cut away from the body that I created in the previous step. So step it back one. So there's the initial extrusion from the floor up. And then step it forward. That's where I extrude the profiles through to cut out the wall of it. And then I continue along with this. I add that portion of the wall there. I trim away some of the bottom where the tabs are going to be, at least on the flat portions. In this case, I thinned out this part of the metal so it's easier to bend when you get it.
So that's also not going to be a Send Cut Send bend?
Correct.
Interesting. Okay.
Yep. And this isn't super difficult material to bend, but with a radius that tight, I wanted to make the wall a little bit more narrow so it's easier to get the radius you need.
Yeah.
And then,
But also, part of the curve in particular doesn't matter too much if you don't get it exactly right, because it's not involved in the ball deflection through the path.
right.
Yeah. Okay.
Yep,
Interesting.
exactly. It's just really an interior guide.
Yeah.
Keep the ball from getting stuck and whatnot. I then created a sketch that I use for opto mounts, so those snap-in optos. I have the whole pattern on here within the tolerances of send cut send for the spacing of the hardware. So I cut the hole on that wall. And then let's continue along here. So then I extend the tabs that are going to mount to the bottom up from the play field. Those will have to be trimmed out later. And then what's the sketch here? That's just a end profile for the flange, because this one was giving me problems on creating the flange. So I extrude that and model the flange as such. And then I do the same thing one more time for the left wall. So there's the start of the left wall. Again, I extrude that profile across it. Let me go away. Stop it. There we go. So I trim it, get the profile. I add the top portion for the outside of the wall there. I design in some relief. So again, it's easier to bend and it doesn't look as clunky when you're staring at it. And then same thing with the sketch for, I believe this is what this one is. Yep, so the holes were added up here for the opto snap-in thing.
Sure.
And then, what's this one? This one is right ramp bottom, so I created, so this is on this plane of the ramp, a sketch that I created to understand where the walls intersect it. So when I extruded that geometry up from the play field on these guys, it allowed me to do on this sketch a project intersect function that tells me exactly where that line is crossing in the flat of this bottom. So I draw that out there. I don't know what operation that one just did. Did something. That one did something. I don't know what they did. Okay, so this one is the unfold operation. So when you're in sheet metal design, if you go up to the modify on the sheet metal component and click unfold, it'll unfold the entire flat and allow you to do work on it in its flat state. So if I step this, or if I just edit this, you see it highlights the bends, and you see how it kind of flattens it out into one flat there. So if I uncheck the unfold all bends, and maybe it doesn't want to do it right now because we're stepping through this. Either way, when you do a flat, it'll automatically detect the bends as long as you have your side profiles designed with the correct tangents and everything. It'll unfold them all. Let me cancel out of that and we'll keep stepping through this. And this is like a quick start guide and overview on how I design ramps. So then I do a sketch.
The stuff you're saying, I'm like, oh yeah, completely get it. And then other half, I'm like, I have no idea what the hell you're saying. Crazy.
So this sketch here was where I was designing the spring steel portion of it. So this is the part where I designed, let me, is it right ramp here? So on this sketch, which it's really hard to see right now, but I actually modeled or sketched out the spring steel, like the curvature of it, and kind of see the profile of it there. So when I'm doing the flat drawing here, I'm marking where the flat portion of the spring steel is going to be against the ramp when you rivet it in place. Hide that again. Oh, just did the wrong thing.
Does send cut send do the spring steel as well?
They do. Okay, next. That was me extruding maybe ketchup. Yeah, so that was me. So one of the issues that you have when you design ramps this way and you do the curvature and then you trim away at it, when you do the flat pattern, you don't have perfectly straight edges because of how you trim away the curvature. So if I come back and look at this sketch, we'll step it back one. If I zoom in, look at the sketch. There. Okay, so if I zoom in here, let me hide the other walls. And let's just look at the right wall over here. Or the right edge. Let's find a good spot. And perhaps it's easier if I hide the sketch too, so you can see. Right here. So you can see the way the camera's positioned, you shouldn't see the edge of that sheet metal. Because you're in orthographic view, this should just be a nice clean-cut edge. And when you're doing sheet metal files for SendCut Send, you can't export a DXF if it doesn't have clean edges. So you can see that edge is like angled because of when this was like folded in its designed position, and you trim away those sides, and then you go and flatten it out. Now you have like weird angles going on. So I create a sketch with some offsets. I trim away 1/16 of an inch in. So let me step that. And then I add back on according to this profile, so we have nice clean edges. And then I add on this little bump out around the tabular stick through. And again, we're still in the unfolded mode here. I then add some fillets to round out some of the edges, like this inside edge here. Make that a little bit cleaner.
Just
then,
because that's like the precision or the curve of the actual cutting they're going to do.
No, so you can have sharp corners in your file. They will automatically like add the curvature. This is cut with fiber laser, so they can get pretty dang tight corners.
Oh. Okay, it's not
Yep.
a metal tool. Got it.
But like if you were designing polycarbonate, I try to design in the radius of the inside corners for the router bit because that's routed material. You can't cut that with fiber laser because cancer and stuff. So I try to design that in, but they will just like run the toolpath and it'll account for that corner. It won't be a perfect sharp corner. It'll be rounded. And then we go back to this last operation of the unfold, and it refolds it back down into position. So that's how I edit the bottom, and then I repeat that operation essentially for the other walls. So unfold the right wall, do some trimming to clean up the edges where we had those weird angles, do some fillets to smooth some of the corners because you don't want to cut yourself on sharp metal, and then refold it. And then we'll do the same thing with the left wall. Trim up some of the edges, clean that up. And then fillet to round off the corners, and then refold it. And how much more do I got here? I got a little bit more. Okay. And then now I'm creating the spring steel down here. So again, that side profile sketch, I extruded that. I put the holes in it for the rivets and round off the flat portion on the ramp. And then trim out the bottom and how that's gonna look. And then for the round part, I actually unfold this steel. So again, to do unfold, you have to convert a body to sheet metal. And in order to convert a body to sheet metal, it has to be consistent thickness every part of the way around it. So unfold that, create another sketch to smooth out those edges, and then refold it. And then I get into this part of component insertion. Let me hide these sketches so we can see what's going on. So I add the spacers and standoffs. So all of these are available in McMaster Car's website. And there's a functionality within Fusion 360 where you can do insert McMaster Car component. So all you gotta do is go search for the exact component you want, copy the part number from McMaster Car, and it'll pull the model in. So like these standoffs, I just searched for a 1.5 inch standoff that's 832 male, 832 female. Brought that in. And
Nice.
then add those in. Then I start inserting the press-in hardware. I have those files locally. So you can see those standoffs being added in. And then this one, new component. So there's my bracket for the clip-in optos. Right there. So I create that as a component. And then I don't know what that one was doing there. But then I bring in the clip-in optos that I have the models of. Then I create a sketch for the polycarbonate that goes on top to keep the ball from flying out.
Right.
Extrude that. And then for the side over here, where this is going to be dropping off this ramp, I also created some polycarbonate guides that you would rivet onto the walls there. I experimented with a bunch of different designs on like metal, and it just looked too clunky over there. So I went with these polycarbonate rail extensions that sit over top of where the drop ramp is.
Okay, gotcha.
And that is the end of
Nice.
the design. And
That's
so there
wild.
is your complete ramp. So when we do
Very
the BOM
cool.
export of this, it should list everything out as part of this assembly.
Right.
So super fun. This took me a couple days to do each of the two ramps. Yeah.
Cool. That's very cool. Very, very impressive. Like I said, like a lot of that, I was like, "Whoa, I don't know what you're doing in this program at all." And some of it, I'm like, "Oh yeah, no, I get that part." So I'm gonna have to watch this back later.
Yeah, it's a lot. Here's the
And you're like, "Oh,
launch lane.
and all the rest of what I did too. No problem." What's with the scooping there?
This,
Yeah.
that's the launch lane ramp. So these are your different skill shots.
Oh, I didn't see there's the holes through. Yeah. Okay, so you're jumping over. Yeah. Got
Yeah,
it.
you're essentially jumping over them, and then it gives it a spot to roll back into. And then this giant drop point here is so that when we do the drop ramp, which I don't know where that went. Base. Apparently the body's hidden. There we go. So there's the drop ramp.
So is that hinging on the side there? So it's always going to stay with the player side in connection, but it tilts down? Or
Yep. So it stays up, and then I'll bring the coil mech in here too so you can see that.
Sure.
So this is the mech underneath.
Oh.
Got latch up and then a spring on the bell plunger to pull it down with enough tension. And then I'll
I
create
see.
a little oval shaped linkage here.
Got it. So it's actually that's the part that's dropping, and the other end is pivoting in place, right?
Correct, yeah. So you can see a surface mount hinge right here that you would rivet in place. And then this launch ramp assembly design is kind of like your hinge point, so we just got to make sure that's secured to the wood rail and the play field appropriately. And I think I did
Nope,
that.
I'm actually more confused now. I don't see how it could hinge right there if you're pulling or pushing right there.
So you can kind of see right here I have
Okay,
a...
now I see. The throw isn't... It doesn't need the biggest throw because the far end is what's moving up and down.
Correct. Yep, your pivot point being like only 1.5 inches out from the hinge gives you a lot of movement with just a little bit.
Okay. Interesting.
So this is the same mechs that I used on my homebrew that work pretty well, except what I did for my homebrew is these were 3D printed extensions that you put into the bell plunger.
Gotcha.
Send Cut Send now offers machining services, so you can order these in bulk machined out of aluminum for pretty comparable to what you would pay for a Marco bell plunger.
Gotcha. That's cool.
Yeah, so I intend to order quite a few of those.
Okay.
So yeah, that's that whole right ramp assembly. So on skill shot and on plunge, the drop ramp will be down and the ball will drop into orbit. But when you shoot this right ramp and the drop ramp is up, it'll feed your right power lane by dropping into this hole here.
And the sheet metal is rigid enough that even though your support is so far away from it, it's not gonna like take a ball falling on it and just like rattle it down or something. I don't know.
Yeah, it should be fine. It holds up really well.
Interesting.
And you know, if the sheet metal has that issue, which it shouldn't, because I haven't had that problem yet with mine, though this one is a little bit longer, you can cut it out of polycarbonate and then design a little bracket that mounts underneath it to attach to the coil.
Okay.
So either would work.
Dang. Okay. Cool.
Yeah, so that's ramp design. Metal ramp design. Right, wrong, or indifferent, that's how I do it. I'm sure all the wizards out there that work for the manufacturers have probably some way they do it that's faster or more efficient, but this is the way I found that I was able to do it. And be able to export the flat pattern files.
Yeah, that's very cool.
Yeah. So we are 20 minutes over time. So I appreciate y'all hanging out and sticking with me through this. Alex and Ernie and Jeff.
For sure. Any last comments from the viewers?
I don't see any. Any last comments from the team?
Nope.
No, there's a lot of work still to do, but it's coming together.
Oh yeah, there's still tons to do.
Should be some fun changes this weekend.
Yep. Wait, what do you mean?
Well, potentially a cab to stab everything in.
Haha, yeah, that would be awesome. Cab would be sweet.
Yeah.
So I'm working on, and I'll probably finish this up tonight and tomorrow, is the redesign of the left ramp with a proper vacuum form buck. So I have the profile sketches ready to go. I just need to do some extruding, but the important part was I needed to get the recession profile for the playfield so I can get that in there and then get the DXFs off to Eric so he can work with some updated files for the artwork.
Right. Nice.
So a few more things to extrude and carve out in the playfield here, and then I'll export the sketches and get those off. And then lots and lots to do down the journey here. And time keeps getting smaller and smaller. But the physical part of it, I think, should be pretty cemented at this point.
Yeah.
Cool. All right.
Nice.
As always, this is PinForge. We are making open source pinball available so people can build their own pinball machine, and also recording videos to make it as easy as possible for them to do so. Providing all the files, full bill of materials, instructions, working with the artist on the art. Eric has been awesome, and also he did the sculpt that you see on the screen there. So this has all been entirely, to this point, mostly funded out of our own pockets. But if you believe in this endeavor and you want to see this become, something that's a mainstay in the pinball world where we're creating more and more open source kits or whatever, or you just want to help support us financially, please feel free to join our Patreon. There's some perks that come along with that. Or you can donate through PayPal if you want. Neither are a requirement. Again, this is going to be free and open source, but it is greatly appreciated if you do donate, because it is not cheap iterating through design, and we don't have the manufacturing facilities of some of the manufacturers. And the prototyping facilities, I meant to say. So, also that money can go a long way to help improve the quality of the stream, getting some of the team better cameras and microphones and better lighting, because Ernie always sits in the cave when he's on the call. So that will be used in that fashion as well, but not a requirement. Big thank you to our current and past patrons. Really appreciate your support to this point. It has gone a long way in helping with this project. Greatly appreciated. And we, the other Kyle, the bad Kyle, will be working to come up with some Patreon perks and announcements and Patreon meeting and all that stuff. So we'll do better on that front, but appreciate your support. Round table, anything? All good?
No, it's great.
Cool. All right.
Yeah.
Well, go ahead, Jeff.
Nada.
Cool.
Oh,
All right. So this is PinForge, because when we build together, we forge what's next. Thank you and good night.